This one is Unit 6 from June 2022 paper. Question 1 and 2 we did the last session, so we'll start with question 3. Atoms of an element emit a characteristic spectral lines when they are bombarded with a beam of high energy electrons. The spectral lines can be used to identify the element. The relationship between the atomic number and the frequency for the most intense spectral line is given by this formula, where k and n are the constant, why the graph of log z and log f would be a straight line. So first you have to simplify this equation. Like this equation, z is equals to k raised to power fn, k f raised to power n. Now we'll take log both sides. So this will become log z, this will be log k multiplied by f raised to power n. In log, whenever two quantities are multiplied, like if it is log a into b, we write as log a plus log b. So this was equals to log z is equals to log k plus log f raised to power n. And whenever in a log, if something is a power, we write as a coefficient, so it will become b log a. So this will become n log f. So when we further simplify, so log z is equals to log k plus log n log f. Now if we rearrange, because we are plotting the graph between log f and z, so we want to compare with the equation of straight line, which is y is equals to mx plus c. So the quantity which is on y-axis and x-axis, they are opposite next to equal to. So log z is already there. If we rearrange, it will be n log f is plus log k. Then we compare with the equation of straight line. Equation of straight line, y is equals to mx plus c. So on y-axis, if we have log z, on y-axis, if we have log z, on x-axis, if we have log f. So if we have log z on y-axis and we have log f on x-axis, what will be our gradient? Our gradient will be equals to, so m is equals to n means, and where n is constant, it means the gradient is constant. So whenever gradient is constant means it will always be a straight line, which is passing. In this case, it won't pass through origin because there is a y-intercept, as log k is a y-intercept. So the straight line will not pass through origin. In part B, the table shows the frequencies for the most intense spectral line. So we have to plot a graph between a log z and log f, in which the log z is there on y-axis. You should not convert the value of f from 10 power 15 hertz to hertz. Like no need for conversion. So we want to plot a graph between log z and log f. And as I mentioned, like we don't have to convert into hertz. So what are the units we will write accordingly? Because as we don't, just we want to take a log of that number, 10 power 15, we don't want to convert into hertz. So this will be log z and then log f. And whenever you mention like this is spectral line, then this will be log f you are taking and then 10 power 15 hertz. Because you are not converting that into hertz. 10 power 15, we are not converting the whole. We are just taking a log of this value. Just take a log of this value and substitute here. Then you have to plot a graph. The graph part will skip and then determine the value of n. How you determine the value of n? As already we rearrange the equation and determine the value of k. How to do this? Because we were having a formula when we solve that equation, that log z is equals to n log f plus log k. That is what the equation. So and when we compare with the equation of straight line y is equals to mx, on y-axis if we were having log z, on x-axis if we were having log f, what was the gradient? The gradient was m. So basically what you have to do, you have to work out the gradient y2 minus y1 over x2 minus x1 from your graph, and that gradient will be equals to n. How to determine the value of k? As you can see, log k is a y-intercept. So when you plot a graph between log z and log f, your graph will not start from the origin. So it will have a y-intercept. So somewhat your graph is like this. So using the y-intercept as a y, this is a y-intercept. So y-intercept is equals to k. So the value of a y-intercept from your graph, that is not equals to k, that will be equals to log k, because y, so then you have to take anti-log. How to take anti-log means 10 power of the y-intercept. That will give us the value for k, and we substitute here. But both parts are related, like you can solve them by from the graph after plotting a graph. A scientist named Henry mostly suggested that z is proportional to f raised to power zero point 0.5. Explain whether the graph support this suggestion. So if two quantities are directly proportional, their ratio will be constant. So what actually you have to do, like you have all the values. So if these two quantities are directly proportional, like z is proportional to f raised to power 0.5, and we have this, the original formula that log z is equals to n log f plus log k. That is the original equation when we modify. So from this, how we can prove, like according to his suggestion, how we can prove. So example, when two quantities are directly proportional, ratio is constant, or if we make a log both sides, so log z is equals to log f raised to power 0.5, or log z is equals to 0.5 log f. So what does it mean? It means the gradient should be 0.5. The gradient of the graph, because like y is equals to mx, so gradient of the graph should be 0.5. So this part, like after working out the gradient from, you already worked out the gradient, the value of gradient n here, and here 0.5 is there. So what you have to do, you have to compare this value of your gradient or value of n with this 0.5. So if you find that the gradient is 0.5 or within that range, then you will say yes, the scientist suggestion supports the graph suggested, the scientist suggestion. If it does not, like if for example the value of n might be say 1.2, and your the gradient is 1.2, and according to scientists the gradient should be 0.5, so it does not match, so you will say the result does not match the suggestion, or the graph does not support the suggestion. Moving on to question 4, a student measured a metal nut of a type shown below. The student measured a diameter of the hole in the center of the metal nut. She made one measurement in a centimeter using a vernier caliper, and one measurement in millimeter using a digital caliper. The photograph shows the measurements. Explain why digital calipers would be a better choice of instrument for this measurement. You should include calculation in your answer. So how we read first, how we read a scale, like here it is written 6.58 millimeter, and this one in centimeter. How to read a vernier caliper? Vernier caliper is main scale. The this vernier caliper, this is a digital. Directly we get the answer. Main scale multiplied by vernier scale plus vernier scale multiplied by 0.01 centimeter. That is how we use a vernier, the scale of a vernier caliper. So main, and how to read the main scale or the vernier scale? Main scale is a point which just passes, like if I zoom in, so what will the main scale reading? This is a vernier scale. This is a vernier scale. This is a main scale. So this is a vernier scale 0. The point with just the main scale passes, that is called a main scale reading. So like this is 0.5, so this will be 0.6. What about the vernier scale reading? Because the formula is main scale plus vernier scale times 0.01 centimeter. So main scale is just the point with the vernier scale passes. What about the vernier scale reading? The line which coincides with the main scale, that is called a vernier scale. So if you see which line coincides, so this is the line which coincides, one over the other. So the vernier scale reading is how much? The sixth line is there, so 6. So 0.01, and the main scale was 0.6 was there. So 0.6 plus 0.06, so 0.66. That is centimeter. If we convert into millimeter, so it will be 6.6 millimeter because we multiply by 10. So according to the digital caliper, the value is 6.58. According to vernier normal caliper, the digital vernier caliper is 6.58, but we are getting 6.6. So first thing, because it's a 4-mark question, you're supposed to say the vernier caliper and the digital caliper reading. So first thing, the vernier caliper, the reading of the vernier caliper is 6.6 centimeter. Sorry, millimeter. Centimeter was 0.6. So that is in millimeter. And the digital caliper, the value is 6.58 millimeter. That is a first thing. But why we prefer to use a digital caliper rather than a vernier? Like it's a better choice. So if you see the digital caliper, if we compare the uncertainties in the value, the percentage uncertainty, what is the percentage uncertainty? The uncertainty divided by value recorded into 100. That is like percentage uncertainty is uncertainty divided by value recorded into 100. So if we want to work out the uncertainty of the vernier caliper, the smallest value which it is recording is usually like 0.01. But in this case, these 1, 2, 3, 4, like the vernier caliper scale, 1, 2, 3, 4. So 10 lines are there. So it is about 0.05. You can write 0.01. It is also acceptable because it depends on, we can have a vernier caliper with the smallest half resolution or full resolution. So even if you write 0.01, that is also fine. So 0.01 you can write, or 0.05 divided by value recorded. The value which is recorded is 6.6 into 100. So this will be 1 divided by, because 100 is multiplied, so it will be 1 divided by 66. And my sorry, 1 divided by 6.6. So you have about 0.15%. And if you use a digital caliper, the smallest value a digital caliper is recording Usually, because when we use a vernier caliper as the two scales we are, and for this one in millimeter, uncertainty is 0.005. Like it can measure to usually 3 decimal places divided by value recorded, which is 6.58 into 100. So this will be about 0.08%. So one thing we can compare the percentage uncertainty. Percentage uncertainty is uncertainty divided by value recorded into 100. So digital caliper is having a smaller resolution or a smaller percentage uncertainty as compared to that of the normal caliper. Another thing why it is also a better choice, because this one will have a parallax error when we are measuring the value. In the measurement, we'll have a parallax error, but here we don't have a parallax error. So these are the points you will mention. 2 points for calculation, 3 points for calculation. One is for the parallax error. Student determine more accurate value of a D. Suggest one technique she should have. So for accurate value, what she should do, she should repeat for different orientation and take an average. And why repeating with different orientation? It will reduce the, so students should repeat with different orientation of the nut and take an average, which will reduce the random error. Or you can also mention like look perpendicular, avoid a parallax error, or check for zero error also. This will reduce the systematic error. Student record the following measurement, determine the mean value and uncertainty. How to determine? First thing, you have to check the data should be in the range. If any one of the values higher or lower, like anomalous result, you will ignore that. But in this case, 6.57, 6.58, 54, 52, so they all appear in the same range. So when we are taking an average, we will add them and we divide it by total number, which is 4. This will give us the average value of a D. But how to work out the percentage, how to work out uncertainty or the percentage uncertainty? That is a half range formula, like maximum minus minimum. So the average will be 6.55. But how to work out the uncertainty? Uncertainty for a group data is a maximum minus minimum divided by 2. That is called the uncertainty for a group data. Like when we have a different set of results and we want to work out the uncertainty, it's maximum minus minimum divided. So maximum value 6.58 and the minimum value 6.52. So 6.58 minus 6.52 divided by 2. This will give us the uncertainty, the half range, which is 0.03. The student was given a different size metal nut. She measured the distance and show that the uncertainty in A is about 0.01 centimeter square. So we have this formula. Look, whenever values, like you can see how A is calculated. A is calculated by under root 3 divided by 2 multiplied by S square minus pi by 4 D square. So these are constant, like pi is constant, under root 3, 2, 4, these are constant number. So means uncertainty in A, or first we'll work out the percentage uncertainty in A. Percentage uncertainty in A is equals to percentage uncertainty in S square plus the percentage uncertainty in D square. But the later part, we want to work out the uncertainty. So the percentage answer, after working out the percentage uncertainty divided by value recorded into 100. We'll have the percentage uncertainty. Value recorded means like when we substitute these values in the formula, we'll get this value recorded. So then we can work out the uncertainty. First, we'll work out the uncertainty in S square, and then we'll work out the percentage uncertainty in D square, and then we will add. So the percentage uncertainty in S square, the value recorded, that is 0.02. But keep one thing in mind, like the A is 1.88 is there. And if you want to work out the percentage uncertainty, it will be, you don't have to convert the units, because when we are taking out percentage, it won't make difference if it is in centimeter, millimeter, or a meter. We'll get the same percentage. So 0.02 divided by value recorded 16.83, and this will be multiplied by 2. Why? Because it is S square. If it was S cube, multiplied by 3, S4 multiplied by 4. And percentage uncertainty in D square, so this will give us 0.24%. Then percentage uncertainty in D square, that is the uncertainty in D, which is 0.04 divided by value recorded 8.55 into, this should be multiplied by 100 as well, because we want to convert, this should be multiplied by 2 and then multiplied by 100. So we get the percentage uncertainty, which is 0.94. So 0.94 is the total percentage uncertainty in the value for D, and it is in the value for S square. Now, this 0.24, if you want, because in the question we need the uncertainty. This is a percentage uncertainty. Percentage uncertainty in A is equals to percentage uncertainty in S square plus the percentage uncertainty in D square. But in the question we need uncertainty. So uncertainty in A is equals to uncertainty of S square plus uncertainty of D square. So this is S, but that is in millimeter. S is given in millimeters, so we want in centimeters. So first what we can do, we can convert this into centimeter. So uncertainty in S square plus uncertainty in D square. So how to work out the uncertainty in S square? So first we work out the value for S square. S square will be equals to, this is divided by, because converting centimeter into millimeter into centimeter, divide by 10. So this is equals to 1.683 and then square. This will give us the value of S square. So 1.683 square, and then this will be 1.68 square. After getting this, the uncertainty is 0.24. So like finding 0.24% of this, because this is a value of S square, but we want the uncertainty in S square. So uncertainty in S square will be equals to 0.24% of this value. This will give us how much uncertainty in there. So 0.0068 centimeter square. That is the uncertainty in S square. So uncertainty in S square is 0.0068 plus the uncertainty in D square. So first, what is the value of a D square? So value of a D is equals to 8.5 centimeter. We convert into millimeter. So it will be 0.855 and then square. This will give us the value of a D square. But what about the uncertainty in D square? Because the percentage uncertainty in D square was 0.94%. So we'll work out 0.94% of this value. So 0.94% of this value is 0. So 0.94% of this value is 0.0 0.00687%, 0.00687 centimeter square. So we get the percentage uncertainty, we get the uncertainty in S square, and we get the uncertainty in D square. And now we have the total uncertainty. What we have to do, we have to just simply add them. This is one method of getting the uncertainty in D. There's also another method. Means the variation of in the value for variation in the value of A. So, and the second method to get the variation in the value of A is equals to 1.88 centimeter square is given to us. That like, but we have to show the uncertainty is about 0.0. What is the meaning of uncertainty? Like variation, like the variation between our maximum and the minimum value is about 0.01 centimeter square. This is a mean value 1.88 is given. So how you can work out the maximum value? The maximum value of S will be equals to 16.83 plus 0.02. This will give us a maximum value of S. And what is the maximum value of a D? 8.55 plus 0.04. This will give us a maximum value of D. We substitute the maximum value of S and D, but don't forget to convert the unit. This will give us a maximum value of A. The second thing, you can also get the minimum value. How to get the minimum value of A? If you want a minimum value of S, so 16.83 minus 0.02. This will give us a minimum value for S. And same thing, 8.55 minus 0.04. This will give us a minimum value for D. And then you will substitute. Don't forget to convert the unit. This will give us a minimum value for A. So we have the maximum value and the minimum value. When we subtract the maximum minus minimum, what we get, and this will give us the uncertainty in the value of A, like how much variation can happen for the value of A. So this can be done in different manner. The first method, as I show, that you work out the percentage uncertainty in S square, then you work out the uncertainty in S square, then you work out the percentage uncertainty in D square, and then uncertainty in D square, and then just add the two values, you'll get the total uncertainty. But add the two values and substitute in the formula. Don't just add the two values. Like after getting the uncertainty in S and uncertainty in D, you can substitute in the formula and you'll get the value for A, and that value of A will give us the uncertainty in A. That is one method, which is a long method. The second method, what I explained, you get the maximum value for S, you get the minimum value for S, then you get the maximum value for D and minimum value of D, and then find the maximum value in A and minimum value in A, and subtract, you will get how much difference is there, or that will be the uncertainty in A. Is it clear? Okay. The next one, do we have to divide the difference by 2? No, in this case, we don't have to divide the difference by 2. That is the half range. Like when we work out the half range formula, then we divide. Like if we have two values, if we have only two values, then we don't divide that. Like example, say if the question was calculate the uncertainty and I was having a two values only for D. When we have the two values, we just do maximum minus minimum, but we don't divide by 2. But if we have a range of data, group of data, then maximum minus minimum divide by 2. That's called a half range. For two values, no need to divide by 2, just maximum minus minimum. But for group data, yes, you should divide by 2. The next one, determine the density of a metal which a nut is made. So using a formula, density, actually density is mass over volume. So how to work out? So density is mass divided by volume, mass in gram. But keep one thing in mind, the unit should be correct. Like here it is millimeter, centimeter square. So this will be 10.3. And what about the volume? Volume is area multiplied by thickness. So area is 1.88. 1.88 multiplied by thickness, it should be in centimeter. So you divide by 10, it will be 0.792. This will give us the density of the nut. The density of a steel ranges from 7.85 to 8.03. Deduce whether the nut could be made from steel. So the best way for a comparison is a percentage difference and percentage uncertainty. Like you work out the percentage uncertainty and you work out the percentage difference. If the percentage uncertainty is more than the percentage difference, it means they are same. But if the percentage difference is higher than the percentage uncertainty, they are not same. So when we work out the density here, by substituting the values, it will be 6.91. This density is there. And this is a standard density of the. So first we'll work out the uncertainty in density. How to work out the uncertainty in density? Density is mass over volume. So it will be percentage uncertainty in M plus the percentage uncertainty in X plus the percentage uncertainty in A. We add, and how to get the percentage uncertainty? That is the uncertainty divided by value recorded. So 0.1 divided by 10.3. When you're calculating a percentage uncertainty, that time unit conversion is not important. Multiply by 100 because percentage is there. This will be 0.01 divided by 1.88. That is the area. And this one X into 100 plus 0.03 divided by 7.92 into 100. When you add, you get 1.88%. Now, how to work out the percentage difference? Because our value is 6.91. So when we compare the percentage difference, we compare with the smallest value, like because 7.85 and 8.03 is there. So this is a like our the close 6.91 is there. So smallest value, which can be closer, that we are calculating a percentage difference. So percentage difference is a maximum standard, like the closest standard value 7.85 minus 6.91 our value divided by the standard value 7.85 into 100. Because we are comparing, like, because the range for a steel is given that 7.85 to 8.03, 7.85 to 8.03. So if our value is 6.91, so which value is closer to us? That is 7 point. That's why we are comparing the percentage difference between these two values. It's obvious, like if I calculate for the 8.03, it will be higher. But what if this answer was like, say 8.2? So if this answer was 8.2, then I'll calculate a percentage difference with this higher range value. Because the next value, which is closer, from that we calculate the percentage difference. So percentage difference here, it will be 12%. So percentage difference is 12%, but the percentage uncertainty 1.88. So if we have like percentage difference for a lower greater value is greater than the percentage uncertainty, so it means it is not made up of steel. So, whenever a question is there, you compare the percentage difference with the percentage uncertainty. If percentage uncertainty is higher than percentage difference, you will say yes. If it is opposite, you will say no. This question is a common type of a question in which you have to compare. So this was the last question related to June 2022. Paper